Hey guys, we're still looking at 5.2 graphing standard and intercept form practice. So now we're going to look at the intercept form of quadratic functions. So this is y equals a multiplied by x minus p multiplied by x minus q, where a is our coefficient and p and q are our constants. And then flipping those signs on p and q, those will be our x-intercepts, so the opposite signs. So let's look at this. It says create a table of values for the quadratic functions and then graph each quadratic function. On the graph, mark the locations of the following significant features of the graph: the axis of symmetry and the vertex. Then determine the key characteristics. So our first function is x minus 1 multiplied by x plus 3. So go to the table function on your calculator and enter in parentheses x minus 1, close parentheses, open parentheses again, x plus 3, close those parentheses. So let's start our table where x equals negative 3. When x is negative 3, our y value is 0. Where x is negative 2, our y value is negative 3. Where x is negative 1, our y value is negative 4. Where x is 0, our y value is negative 3. And where x is 1, our y value is 0. So guys, if I were to identify p and q, in this case, my p is negative 1, my q is positive 3, I would need to switch or change those signs to do the opposite signs to get my x-intercepts. So I should have one x-intercept at 1, 0, and one intercept at negative 3, 0. Looking at the table, those are our two x-intercepts. So I know I'm going to have a point at positive 1, 0, and an x-intercept at negative 3, 0. If I'm also looking at my table, I can find my turnaround point, which is going to be my vertex. So in this case, it's at negative 1, negative 4. And then let's just graph the rest of those. Let's just plot the rest of those points. So I've got negative 2, negative 3. So to the left 2, down 3. Then I've got the point 0, negative 3. So I'm just going to go down 3. So that's our y-intercept. And those are all 5 points there. So we can connect them. And we now have our parabola. So like I said, our x-intercepts are at negative 3, 0, and 1, 0. Our axis of symmetry is going to pass through our vertex. So this is the vertical line through our axis of symmetry, which in this case is going to be where x equals negative 1. Our vertex is at the point negative 1, negative 4. Our y-intercept is at 0, negative 3. And if we look at the end behaviors of this parabola, on both sides, our y is approaching positive infinity. So therefore, this opens up. And our vertex is our minimum point. Let's go on to the next function. So y equals 0.5 multiplied by x minus 4 multiplied by x plus 2. So we're going to enter that into our calculators. Make sure you include the parentheses. So let's start at negative 2. So where x is negative 2, y is going to be 0. Let's go to where x is 0, y is going to be negative 4. Where x is 2, y is negative 4. Let's include where x is 1. So where x is 1, y is going to be negative 4.5. Where x is 2, y is negative 4. And where x is 4, y is 0. So first thing we got to look for are our x-intercepts. So in this case, I know my p-value is negative 4. So opposite of p should be positive 4. So I'm going to have an x-intercept at 4, 0. My q value is positive 2. Opposite of positive 2 is negative 2. So my next x-intercept is at negative 2, 0. So we can go ahead and plot those 2 points. So So my x-intercepts are at 4, 0, negative 2, 0. And let's go ahead and graph the rest of these points. So when x is 0, y is negative 4. Anytime where x is 0, that's our y-intercept. Let's see here. Where x is 1, y is at negative 4.5. That looks to be our lowest point, which is going to be our vertex. Then where x is 2, y is going to be at negative 4. And we already have the point 4, 0. So let's draw our parabola here. If I'm looking here, our domain for all functions is going to be negative infinity to positive infinity, which is the same thing as saying all real numbers. Our range is going to start at the bottom of our vertex, so the lowest value for our y is at negative 4. So it's going to include negative 4 and approach positive infinity, or you can say that y is greater than or equal to negative 4. Our vertex is at the point, negative 4.5. Looking at our table, our turning point is at 1, negative 4.5, so that's our vertex. And our axis of symmetry then is where x equals 1. And our end behaviors on both sides, we're approaching positive infinity, so therefore this opens up. All right, let's look at problems 7 and 8. So problem 7, I'm going to fill in that table again, 2 multiplied by x minus 2 multiplied by x plus 2. So let's start our table off at negative 2. When x is negative 2, y is 0. When x is negative 1, y is negative 6. When x is 0, y is negative 8. When x is 1, y is negative 6. And when x is positive 2, y is at 0. So our x-intercepts here then are negative 2 and positive 2, looking at our table. So negative 2, 0, positive 2, 0. Our vertex is our turning point, which is also going to be our y-intercept, which is at 0, negative 8. Meaning that our axis of symmetry is just our y-axis, which is x equals 0. And if we plot the rest of our points, we got where x is negative 1, y is negative 6, and where x is positive 1, y is negative 6. So there's our parabola. And if we look at our parabola, as x approaches negative infinity, y is approaching positive infinity. As x approaches positive infinity, y is approaching positive infinity. Last but not least, we've got problem number 8. Go to our table and enter in negative multiplied by x minus 1. So that's like negative 1 multiplied by x minus 1 multiplied by x minus 7. Make sure that you're putting the negative sign instead of the minus sign as our coefficient. If it helps you, just put a negative 1 there. So let's start our graph off, our table off, where x equals 1. So I'm going to have 1, 0, 2, 5, 3, 8, 4, 9. 5, 8, and let's add a couple more points, 6, 5, and 7, 0. So I've just extended that table a little bit. We've got our x-intercepts then at 1, 0, and 7, 0. If I look for my turning point is at 4, 9. So that's going to be my vertex. So where x is 4, y is 9. So to the right, 4. And up 9. Let's plot the rest of these points. So where x is 2, y is 5. Where x is 3, y is 8. We've already got 4, 9. Where x is 5, y is 8. Where x is 6, y is at 5. So there's our parabola. Our axis of symmetry is going to pass through our vertex. So that's going to be where x equals positive 4. Our range is going to go from negative infinity to that positive 4, and it's going to include positive 4. So you could say that y is less than or equal to positive 4. And our vertex here is at the point 4, 9. Looking at our end behavior as x approaches infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity as well. So this opens down is a parabola flipped upside down. All right, guys, that's all the practice problems I have for you today. Have a great Bulldog day.